Hello, so today we're going to look at the ambiguous case for the cosine rule. So like the sine rule, there is actually an ambiguous case to the cosine rule. So there's actually a case in which we could actually get two different triangles basically, or two different values for the length of the triangle. So let's look at this example here. Let's say we've got 27 degrees. So this is an angle. I'll just call that an angle A. We've got a side here, 13. It's got a side next to it. I'll call this S for side. And we've got a side next to that, a side there. So you've got another one of these SSA situations. So a side next to a side next to an angle. And this angle here is an acute angle. I'm just going to make a note here that this is an acute angle. So it's an angle between 0 and 90 degrees. Okay, so let's say we want to find the base, this like missing length on the bottom there. Well, let's try and use the cosine rule. So if we call this angle there, we'll call it A. So this is going to be lowercase a there. And then this side there, we'll just call that B. It could be either B or C, doesn't matter. So that means that this is going to have to be B there. And then angle C is there. So C is what we want to calculate. We want to calculate C. So want to calculate C. So we're going to use our cosine rule formula. So again, we've got A squared equals B squared plus C squared minus 2BC cos A. Okay, so we've got A squared, which is this 10 squared. So you got, let's just plug the numbers in and see what we get. So 10 squared is equal to B squared, which is 13 squared, and then plus C squared, which we don't know, and then minus 2 times B, which is 13. So 2 times 13 gives you 26. So you get 26 times by C, and then cos A, which is cos 27. So cos 27 degrees. And then now we're going to get an equation. So, if we just do 10 squared, that's 100. 13 squared should be 169. And then plus C squared minus 26. I'm going to write this the other way around. So instead of writing the C first, I'm going to write the cos 27 first. So cos 27 times by C. So basically, this number, 26 cos 27 times by C there. So what we're going to have is we're going to have a quadratic equation. So we're going to get, if we just take away the 100 from both sides, we'll get C squared, and then minus is 26 cos 27 times by C, and then 169 take away 100 will be 69. So plus 69 is equal to 0. So now we got a quadratic equation. So now we can either use your graphical calculator to actually work out the solutions. So you can go to your graphical calculator, use the equation solver. We've got a polynomial of degree 2, so that's a quadratic equation. So the highest power of the missing value is 2, so it's a polynomial of degree 2. And then our A value in this case, in terms of like the quadratic formula, so our A value is going to be the number 1, because we've got like a 1C squared there. Our B value would be this 26 cos 27 value, because that's the number, the coefficient of the C, the C there. And then our C constant in the quadratic formula would be this 69 there, so 69. So we can use our quadratic formula. So minus B plus or minus the square root of B squared minus 4AC divided by 2 times A. We can plug the numbers in, or we can use the graphical calculator to do this for us. So our A value is 1, our B value is 26 times cos 27, and our C value is 69. We can solve the equation, and we'll get two possible solutions. So what we'll get is we get two negative values with this one. So what does that tell us? Well, it tells us that there is no such triangle that exists in this case here. So there's actually no such triangle which makes this exist. Apologies, sorry, I mistyped a number into my calculator, so it won't be a two negative value. Sorry. When you plug your A value is 1, so this should be a negative sign. That's the mistake I made. So your B value into your quadratic formula is going to be negative 26 cos 27. So your A value 1, negative 26 cos 27. And then a C value is 69, solve that equation. So we should get two solutions. So we should get 19.7 as in centimeters, because it's our length, or we should get 3.51. So we get two different we get two different values, so two different lengths here. So it's now ambiguous whether actually the triangle looks like this here with 10 centimeters down here, or whether it looks something like this with 10 centimeters down there. So it's ambiguous whether the length of this base here is going to be the 19.7, or whether it's going to be this small base here of 3.51, because actually this length could be the 10 centimeters going down in this diagonal position, or it could be this 10 centimeters here with a longer base. So it's actually ambiguous. We don't know for certain whether our base is going to be 19.7, the long base, or actually this small base here, because this 10 could be going down there, or it could be going down there. So that's what this is telling us. So we could actually have two lengths, so it's ambiguous. Now let's consider another case. So let's consider something like this time, instead of this one. Sorry, let me change the length here to 15 instead. So 15 centimeters there, sorry. So 15 centimeters there. Let's consider this one. So how could we find the base of this one? So again, we've got the same setup. We've got an angle there. We've got a side next to it and a side next to it. So the profile of this triangle is side-side angle. Again, how could we set this problem up? So we're going to use the cosine rule to work out this base again. So using our the formula as we used before, a squared, we'll call this, if we call this capital A there, that's going to be lowercase a there. If we call this B there, that's B, and that's going to be C down there, the other length. So we get a squared, which is going to be the 15 squared, is equal to B squared, so the 14 squared, plus C squared, which is what we want to find out, minus 2 times B, which is 2 times 14, so 28, times C times cos 27. We can then rearrange to get a quadratic. So 15 squared is 225, 14 squared 196, plus C squared minus 28 cos 27 times by C, like that. Again, if we do 196 take away 225, that should give us 29. So we get C squared minus this 28 cos 27, lots of C, and then take away 29, that's going to be equal to 0. And again, we can use the quadratic formula to solve this, or you can use your equation to solve this. So your A value is going to be 1, so the 1C there, sorry, 1C squared. Your B value is going to be, again, negative, just going to watch out for negative sign, so negative 28 cos 27. And your C value is going to be a negative 29 at the end there. So using your quadratic formula, minus B plus or minus B squared minus 4AC over 2A, or using your calculator to solve this, you'll get this. So plug in A equals 1, B equals negative 28 cos 27, and C equals negative 29. Solve that, you will get, well, you will get one answer. Well, you get one positive answer, 26.1 to 3 significant figures, or you'll get a negative answer, so negative 1.11. So yeah, obviously we can't have negative lengths. So there's only going to be one solution, because obviously we can't have a negative length in centimeters. So only one solution. So this case isn't ambiguous. We actually have one solution. This length must be, I mean, it has to be 26.1. It can't be a negative value. So we know for a fact this length must be 26.1 with certainty. So this case is not ambiguous, but our first case was ambiguous. Now, if we think about this case here compared with this case back here, again, we notice that the opposite side to the angle given in the question is actually bigger than the side adjacent to that angle. Whereas in our first case, where we had this ambiguous case, where we had two different possible solutions, the opposite side there was actually smaller than the side adjacent to the given angle in the question. So we'll bear that in mind. And we'll also consider this example here. So again, we don't really need to do any calculations with this one to think about this one. We want to know how big this side is. I mean, are there two possible lengths of this? No, not really, because if we draw a 20 centimeter line there instead, just by rotating this 20 centimeter line up to there, well, the angle here is going to change. It's no longer going to be 152. So, I mean, that's not a possibility. So it looks like we're only going to have one solution so far. Now let's draw a line in, a 20 centimeter line down there. So rotate it round clockwise. to 20 centimeters. Again, the angle would now change clearly. That's now going to become a bigger angle. So the angle is not the angle in the question. So yeah, with this one, again, this is not ambiguous. So not ambiguous. Because we're only going to have one base when we calculate the cosine rule. I'm not going to use the cosine rule to calculate this base down here, but you can use the cosine rule and you'll get one solution, or at least you'll get one positive and one negative solution. Of course, you can't have a negative length, so you don't need to worry about that. So in summary then, if you are given a side-side angle, so a side next to a side next to an angle on a triangle, so SSA, so like these examples there, so side next to a side, next to an angle, like that's a side-side angle, or like this, side next to a side, next to an angle, and you need to work out the missing side that you don't know on the triangle. There could be, sorry, let me spell this correctly. There could be two possible lengths. And how do we know if there will be two possible lengths? So if the angle they give you in the question is an acute angle, and it's between 0 degrees and 90 degrees, and if the opposite side to the angle A is a smaller number than this B adjacent to the A, so the A is less than B, and again, we've got a side angle profile. So we got side angle. Then there are two possible length values for C. So in this case, if you've got, again, an acute angle A, which they give you between 0 and 90, a side next to it, and then a side next to that, with this opposite side being smaller than the adjacent side next to the angle A, then there will always be two possible length values for C. Now, to determine which is the correct one, which one you're going to pick, the question needs to tell us the value of the angle B or the angle C. So if we know this angle there, sorry, I've done this the wrong way around. This should be B there, and this should be C there. So if we know these two angles, then we can work it out. So I mean, if this B angle there is going to be an acute angle, then we know that this base down there is going to be the bigger base. Whereas if this B angle was an obtuse angle like this, then actually we're going to choose the smaller base value we get when we use the quadratic formula. So if this angle there's bigger, we get a smaller base. If this angle is smaller, we get the bigger base. And similar with this one up here, again, if we get a bigger angle, we can have a bigger base there, but the smaller the angle is, we can have the smaller base there. So you'd want to use basically the sine rule to check actually what is the correct length there. So you want to double check which length is correct, because there could be two possible lengths unless they give you these angles. And if they give you the other angles in the triangle, it's going to be one of the solutions out of the two that you get. So that's just a summary of the ambiguous case for the cosine rule. Every other case for the cosine rule, you're always going to get one solution. But if you have a side next to a side next to an angle, and the opposite length is smaller than the length next to it, and this angle is an acute angle, then there will be two possible answers. So you need to check, does the question give you your other angles? And if it does, you've got to pick the correct one, because there's two possible values. Hello, so in today's video, we're just going to do a complete summary of the sine and the cosine rules. So the formula for the sine rule, well, that's going to be A over sine A equals B over sine B equal to C over sine C. So remember, this is when you have a triangle like this. So for example, A, lowercase a opposite it, capital B there, then lowercase b goes there, and if capital C is there, your lowercase c is there. So that's your sine rule, and we proved that before. Your cosine rule is a squared equals b squared plus c squared minus 2bc cos a. And then when do you use both of them? So when do you use the sine rule? So you use the sine rule if they give you, the question gives you, so you're given two angles and one side, and you need to find a side opposite one of the angles. So they give you two angles, one side, and you need to find a side opposite one of the angles. So that's your first case. There's also another case as well. I'm just going to move this down here. So case 2, is when they give you two sides. So given two sides and one angle, when you need to find, so they give you two sides, two sides, one angle. If you need to find one of the other angles, so one of other angles opposite one of the sides given to you, so that's when you need the sine rule. So when do you need the cosine rule? So if they give you, so given all three lengths on the triangle, so all three lengths, find one of the angles, so find one angle. Or the second case is when they give you, so given two lengths and one angle, find the missing side. So find the one last missing side. So that's the difference between when you use the two. And when is the ambiguous case? So for the sine rule, it's when you've got a side-side angle. So a side next to a side next to an angle. And it's when the angle A is an acute angle. So the angle is between 0 and 90 degrees. So between 0 and 90. Sorry, just rub that out and put an A there instead. So between 0 and 90. Also, when the side opposite, so side opposite A, so opposite this angle, is less than the other side given in the question, so less than the other side. In that case, if that is true, then there are two possible angles. So two possible angles for the one you need to calculate. So two possible angles for the one you need to find. And then how about the ambiguous case for the cosine rule? So that's when, again, you've got a side-side angle. And I'll mention up here again, the ambiguous case of sine rule is when you need to find another angle. So need to find other angle. But the ambiguous case of the sine rule is when you've got a side-side angle and you need to find the remaining side. So need to find the last side. Okay, so it's when you need to find the last side. So again, the key thing again is that A must be an acute angle, so between 0 and 90 degrees. And also, again, the same kind of thing. So the side opposite the angle, so side opposite A, must be less than the other side they give you in the question. So less than the other side they give you in the question. If all three of these things are true, then there are two possible sides for the missing side. So two possible side values for the remaining side. However, if all of these three conditions are not true, there will always be one possible angle. And the same with the sine rule. All three of these conditions must be met in order for the ambiguous case to work. Otherwise, it's just a normal calculation where you have one potential or one possible angle. So that's just a summary of the sine rule, the cosine rule, when you need to use them, and the ambiguous cases for both of them.